Hi people, in this video we consider famous international A-level Pure 1 exam, June 2021. So it's question number 8. The curve C1 has equation y equals 3x squared plus 6x plus 9, so it's a parabola. So part A of the question asks to write 3x squared plus 6x plus 9 in the form of this, which is a completed square form where a, b, and c are constants to be found. So, okay, I have enough space to write down the solution here. So 3x squared plus 6x plus 9 is equal to. So I consider the first two terms. So I take out a common factor of 3. So I have x squared plus 2x. And here I have to decide how much to add to make it a full square. So there is a clear procedure. You take the coefficient of x, whatever it is. It can be a fraction, it can be like an integer. You divide it by 2 and then square the result. 2 divided by 2 is 1, 1 squared is 1. So I have to add 1 to make it a full square. Maybe in this particular case, it wasn't a difficult problem to determine how much to add, but what if it were 2/3? So it would be a problem to find out the number I have to add to make it a full square. So the procedure would be absolutely the same. So you take the coefficient of x divided by 2 and square the result. Next, I can't add 1 just for nothing. To keep the balance, I subtract 1 at the same time. Now I'm sure nothing has changed because adding 1, subtracting 1, so they cancel out and the result is the same as it was originally. So, and then we add 9 outside the brackets is equal to 3. I'm sure this is a full square. Of course, it's x plus 1 squared multiplied by 3. Then don't forget to multiply -1 by an outer factor of 3. So because it's a common mistake made by students. So 3 times -1 minus 3, and then plus 9. Minus 3 plus 9 is plus 6. So that's it. A is equal to 3, B is equal to 1, and C is equal to 6 just by direct comparison. Okay, so let's move on. The point P is the minimum point of the curve C1, deduce the coordinates of P. So it's just 1 mark. So it means we can use the results of the part A because they do not ask us to find it. They ask us to deduce. Of course, we look at the completed square form. So x plus 1. So the number next to x plus 1, it changes its sign to opposite. It becomes -1. And the number outside plus 6. So it doesn't change its sign. It becomes y coordinate of the vertex. So this is the vertex. So it's just 1 mark question. So there is no justification. I do not have to provide any justification. So the answer is ready. So let's move on. A different curve C2 has equation y equals cubic function. It's a cubic polynomial where a, b, and c and d are constants given that C2 passes through P. So P is the point we found in part B. So also, it intersects the x-axis at -4, -2, and 3. So these numbers are roots of the cubic polynomial. So if the roots are given, so I can construct the factors, the linear factors based on each root. So x minus the first root, -4. So it becomes +4. Also, x minus -2. So I take x and then I subtract the root, the x-intercept. X minus 2 is x plus 2, x minus 3. So, but look, when you open the brackets, it will be x cubed, but it must be ax cubed at the end. So that's why y is equal to a times. So this is a subtle moment you have to understand. So the leading coefficient of the cubic function, it remains the same when the polynomial is written in this form, canonical form, or I don't know how to call it, the general form, common form, and this factorized form. The leading coefficient remains the same. So look at this form. Parameter A is the only unknown. So we have this piece of information that C2 passes through minus 1, 6. So we can plug it in and find the only unknown of A. So y equals 6 equals A. Then I put x equals -1. Negative 1 plus 4 is 3. -1 plus 2 is 1. -1 minus 3 is -4. Okay, so let me show you my great abilities in mental counting. So it's minus a half. Find, making your method clear, the values of A, B, C, and D. Oh my God. Okay. So I have found the value of A. So let's put it back. So y equals minus a half, x plus 4, x plus 2, and x minus 3. Now I understand why they give 5 marks for it, because I have to open the brackets in order to present it in this canonical form, and then by comparing, find all the coefficients. Okay, so minus a half. Let's rewrite x plus 4. So let's open the brackets here. It's obviously x squared minus x minus 6. So minus a half. Let's open the brackets by pairing all the terms inside the two brackets. So it's x cubed. Oh, let me show you how I usually do this quickly. So x times minus x, I know it's minus x squared, but this is one more combination that gives me x squared term. So minus x squared plus 4x squared. So it's plus 3x squared. Now let's take a look at x terms. Here is the first pair. Here is another one. So minus 6x minus 4x. I multiply them up. So minus 6 minus 4 minus 10x. And then the free terms or constant terms, 4 times negative 6 is minus 24. Like this. So now I open the brackets. Minus 1/2 of x cubed minus 3 over 2x squared plus 5x and plus 12. So this is A. Okay. This is B. This is C. And this is D. Excellent. That's it. Yep. Next, it's again international level, Pure 1, June 2022. Green color. So it's a question number 10, problem number 10. Okay, figure 5 shows a sketch of the curve C with equation y equals 2 over 7x cubed. Okay, it's a cubic polynomial. Yep. So the shape is identifiable, recognizable. So k is a constant. It's the only parameter. Find dy dx. Okay, dy dx for polynomials, it's an easy task. So we know power of x goes down 6 over 7. X to the power of 2. So the power of x becomes 1 less. Plus 2 goes down. 2 times 1 7 is 2 sevens. x minus. So x disappears, just 5 over 2, and k disappears. So that's it. It's a derivative, dy over dx. Okay, then the line L shown in figure 5 is the normal to the curve at the point A with x coordinate minus 7 over 2. Okay, let's see. So this is minus 7 over 2 by x, and this is the normal. So it's perpendicular to the curve. Given that L is also a tangent to C at the point B, okay, show that the x coordinate of the point B is a solution of the equation. Okay. So let's say the x coordinate of B is, let's say A. Let's say it's A. And look, I can find the slope or gradient of the normal at the point A. So what is it? So first step is to find dy over dx at point x equals minus 7 over 2. I would like to use my calculator. Where's my calculator? So minus 7 over 2. I put that value in my calculator and press equals button in order to save this result in answer. Then I type 6 over 7 times answer squared plus 2 over 7 times answer and minus 5 over 2. Look, I saved so much time because x was minus 7 over 2. So instead of typing it again and again, I saved so much time. So equals, oh, it's 7. So dy dx at x equals minus 7 over 2 is 7. It's by calc, right? It's by calculator. So, but it's a value of the derivative. It's gradient of the tangent. But I'm interested in the gradient of the normal. The gradient of the normal, m of normal, okay? M of normal is the gradient of the tangent, but negative reciprocal. I have to flip it and change its sign to opposite. So it's minus 1 over 7. Flip and change the sign to opposite. So this is the gradient of the normal. So this normal then becomes a gradient of the tangent at B. So this is the most important part of the solution. So the gradient dy over dx at B, at the point B, must be equal to this minus 1 over 7 because it's a gradient of the normal. It's a gradient of the tangent at B also. So it's minus 1 over 7. Okay, the gradient at B. So B has x coordinate of A, and then gradient is this. I put x equals A there. So 6 over 7 A squared plus 2 over 7A minus 5 over 2. This is the gradient of the function at B. And it must be equal to minus 1 over 7. So let me show you the equation. I hate denominators. Everybody hates denominators. To get rid of denominators, I multiply this equation by 14 because it's LCM of 7 and 2. So it's the least number that will allow me to get rid of all denominators. So it's 12a squared plus 4a minus 35 is equal to minus 1. So minus 1 moves to the other side. So 12a squared plus 4a minus 34 is equal to 0. Then I can reduce by 2, 6a squared. Oh, no. Oh, yeah, I can. What's wrong? Oh my God, sorry. It's minus 2. 14 divided by 7 is minus 2. It's minus 33. Yeah, it's exactly what they wanted us to show. So the same equation, but my equation is stated in terms of a. It doesn't matter. It doesn't matter. Hence, find the x-coordinate of b, justifying your answer. Okay, so I see that a, the coordinate of the x-coordinate of b, is a positive number. So this will allow me to distinguish between the two roots of the quadratic equation. So I use my calculator. So I don't want to solve the quadratics using factorization or quadratic formula. So 12, 4 minus 33 are the coefficients. So x1 is equal to 3 over 2, and x2 is equal to minus 11 over 6. Minus 11 over 6 is a negative number, so it doesn't work. So a equals 3 over 2. So x equals 3 over 2. It's x coordinate of b point. Okay. Then given the y-intercept of L is the line, and it has y-intercept of negative one, and find the value of k. Okay, so this must be an easy task. Yep, because oh, how can I know the value of k? Okay, so let's find the equation of L. Okay, let's find the equation of L. I know it has gradient. What gradient it has? It has gradient of minus 1 over 7, right? So let's do it here. D here. So about the line L, it has here, it is gradient of the normal. It's minus 1 over 7. So when I start writing the equation of L, y equals minus 1 over 7x. And now I'm given the y coordinate of, y-intercept. It's negative 1, so I put it here. So this is the equation of L. But how can it help me to restore the value of k? So the key idea is the point B, because my tangent line passes to the point B and my curve passes to the point B, and a coordinate is already known, is 3 over 2. Yep, we found it in part C. 3 over 2. Yep, so if I put 3 over 2 in the curve, and if I put x equals 3 over 2 in the tangent line L, so the results must be the same. So minus 1 over 7 times x, 3 over 2, minus 1. I know these fractions drive me crazy, but I have a calculator, so don't worry. And then I put 3 over 2 in the curve. Oh my God, 2/3 times 3 over 2 cubed plus 1 over 7 times x, 3 over 2 squared, minus 5 over 2 times x, 3 over 2 plus k. Oh my God. So k is equal to, so I don't want to waste my time, your time, so I will just put everything in my calculator and find the value of k, which is 5 over 4. 5 over 4. That's it. So when you review the solutions, or when you see the solutions in the mark scheme or in videos like that, like my video, so pay attention at the key ideas. Look, B lies on L and on the curve at the same time. So L is simultaneously a normal and the tangent. So it says a lot about the derivatives at this point and at this point. So I hope you liked these two problems from international A level, pure one. So see you in the next video. Bye bye.